Hello again, Mr. Hein. And this video, we're talking about transformations again, but the next layer on. So recall from yesterday the three transformations we talked about of translation, which is like you slide an object, a rotation, which is when you turn an object, and then a reflection, which is when you flip an object. Three transformations you can do that won't change the object. And make sure you know how to do these and graph its new points, the prime coordinates. Look back at my old video if you don't know how to do that. Now, what we're going to talk about in this video is two things. So we're going to talk about the first one, which is called rotational symmetry. And then after that, we'll later talk about the second one here, which is reflection symmetry. Now, the word symmetry means if something is symmetric, it's alike. You know, they look very similar. And so what I mean by rotational symmetry is this means you can rotate an object. You can rotate an object and return to its original state before 360 degrees. And notice I say before 360 degrees because at 360 degrees, what's happening? Well, you return back to where you started. So everything goes back to its original state at 360. What we're looking for rotational symmetry is something that rotates back to its original state before 360. Some examples, and you can't use these examples when you look some up yourself. Maybe look up some brand names. But say you look at like a triangle like so. If I rotate this triangle about the middle point here, so if I held this point still and rotated this paper, right, I would be back where I started, right there, back right there. I'm back where that triangle looks the same. One more time, it looks the same at that point. And then lastly, it'd be back at 360 degrees, back in the state it was in. And I don't know if that helps you. So maybe if I use tracing paper, let's see if tracing paper is kind of hard to see in this lighting, but let's see. So I drew my triangle, and I don't know if you can see it, they're on top of each other. But notice if I rotate this paper, I will be back on top, right there. I know it's hard to see. See if I can get the lighting for you. You don't even see it, but it's okay. But you can see if I rotate just slightly, see how they're different. They're no longer on top of each other, right? And then you rotate again and be on top of each other one more time at that point. So maybe another way you can say it is you rotate an object, you return to its original state, or you can say it as like it'll land on top of its original before 360 degrees. So a triangle is an example in which it will rotate, it will land on itself 3 times within 360 degrees. A square, if that were a perfect square, right? If you rotate a square, well, it will return to that same look of a square 4 times within 360 degrees. And you can see that these shapes have rotational symmetry because of that. Now, a little bit more of a challenge for some of you is how many degrees is it when it has rotational symmetry? Well, if it's 3 times within 360, do 360 divided by 3, and you'll see 120 degrees. So for this triangle, every 120 degrees, it returns to its original state. And then if the square here, if you did 360 divided by 4, you'd get 90 degrees. So that's the idea there, is every 90 degrees, it has rotational symmetry. So that's what rotational symmetry is, something that you can rotate it and it'll be back on top of itself before you do a full rotation. Right? Emphasis on the before 360. Right? Now, what's reflection symmetry? It's the same thing, but instead of rotating an object, you would reflect an object and it would look the same. And an example of this is the McDonald's logo. The McDonald's logo looks something like this, of course. It's not perfect, or it's like the M. It's an awful example. But if I was to do a line of reflection down the middle of an M and reflect both of these sides over, it would still look the same. After a reflection, after reflecting both sides, it would still look like the McDonald's logo. So a McDonald's logo has reflection symmetry, and a lot of examples do. I mean, if we just talk about shapes, a circle has reflection symmetry. If you drew it right down the middle, you have a line right down the middle, that line of symmetry, that would still be okay. Now, what's a non-example to help you see this? That would be like if I drew a circle, but my line of reflection is not down the middle. If that was my line of reflection, if I flip this circle over to that side and this circle over to that side, it would not land on top of itself, right? The idea is that it has to land on top of itself. And this would not, okay? So that's what this is about, reflection, rotational symmetry. I hope you can make sense of it, find some examples, look at brand names and logos, because a lot of brand names and logos love to use this type of art in a way in their objects. All right?